Alright, I'm going to make a short video on not really physics but the trigonometry of these momentum problems. I know many of you probably haven't had geometry in a little bit, and those of you who did may not remember exactly a lot about it. So what I have here is I've drawn a triangle, and it's a momentum triangle specifically. You can do it two different ways. You can either do velocity or you can do momentum. And here I've got a momentum triangle. And this is like a sort of hypothetical. We had an elastic collision, so two objects are going two different directions, and you were able to use the conservation of momentum to find the two pieces, the horizontal and vertical pieces of momentum, and you're trying to figure out, let's say in this problem, we're trying to figure out both the velocity of the final object, so the velocity, and the angle of the final object. So this is really a geometry problem. There's not very much physics involved at all. Let's say we know the horizontal piece and the vertical piece. We need to find two things. We need to find the velocity and the angle. I'm going to start with finding the actual velocity. And to do that, I first want to know the hypotenuse here. I want to know how much momentum does this 4 kilogram object have. To get this, you can use the Pythagorean theorem, because this is obviously a right triangle and we know two sides. So Pythagorean theorem says a squared plus b squared is c squared, and we can use that to figure the hypotenuse. So the hypotenuse here is going to be equal to the square root of a squared plus b squared, 5.3 squared.
Following students come to the office at this time.
Plus 3.2 squared.
Dalton Dewey, Hunter Cassidy.
If you're listening at home, you don't have to go to the office.
Cliff, J.P.
But
Ford,
I guess you can if you want to.
Daniel Rowland. Come to the office, please.
So I have my Pythagorean theorem set up here. I'm going to take the square root of, on my calculator, 5.3 squared plus 3.2 squared. Sorry, I typo. 5.3 squared plus 3.2 squared. And I got 6.19 for C. So C is going to be equal to 6.19 kilogram meter per second. That's my hypotenuse in this momentum triangle. Now where people will mess up is they might think like, okay, that's the velocity, but it's not the velocity, that's just the momentum. So to get the actual velocity, we've got to use that equation that momentum is mass times velocity. The momentum is 6.19, and it's equal to the mass, which is 4, times the velocity. So we have just a simple algebraic equation here. Divide both sides by 4. I'm getting on the bottom of my screen here, but I may have to raise it up in a second. And so I take 6.19 divided by 4, and I get I'll round it to 1.55 meters per second. So that's the first part. That's the velocity. So we've already got one of our two answers here. The velocity is good. Now we need to figure out the angle. The reason why I did the hypotenuse first is because to get this angle, we're going to have to use one of our 3 trigonometric functions. Well, if you happen to know all 3 sides, then you can use any of the 3 trigonometric functions to figure out this angle. Personally, if you don't do the hypotenuse first, you still know these 2 sides, and those are actually the 2 sides I'm going to use simply because I didn't really have to round them. That's what they were given to me as. So I have these 2 sides, which for this triangle are the opposite and adjacent sides. Opposite and adjacent. I'm going to use that to figure out the angle. So I need to probably bring this down. And I know you're not going to be able to see what's going on, but you can probably see some things. So 5.3 to 3.2. So I'm going to write this. Sorry, I'm going to pause this. Alright, so you can see I moved all that work down, but again, that's all down there if you need to know it at any time. Well, it's on the previous parts of the video, I guess. And hold on one second. I had a student knocking every time I wasn't reading, so sorry I had to stop there. Alright, so now I'm trying to figure out the angle again. So I can use any of the 3 trigonometric functions. I'm going to use the ones that involve these 2 sides because I didn't round them. But you'll get the same answer no matter what. For this triangle, those 2 sides, for this angle here, this is the opposite side and adjacent side. So if I go through SOHCAHTOA, I'll write it out, it takes like 2 seconds. SOHCAHTOA, if I'm going through these two sides, only one of them has opposite and adjacent in it, and that would be tangent. So I'm going to write out my tangent statement, and it says that the tangent of an angle, theta, equals opposite over adjacent. For my triangle specifically, the tangent of, I don't know my angle, is going to be equal to opposite, which is 3.2, over adjacent, which is 5.3. And I'm just going to simplify 3.2 divided by 5.3 gives me the tangent theta is going to be equal to 0.6038. I rounded some, obviously. So what I'm looking for is an angle that when I take the tangent of the angle gives me 0.6038. So theoretically, one way you could do this is to punch in angles until you get and take the tangent of different angles to get 0.6038. But that's not a really efficient way to do it. What you really want to do is get theta by itself. Now, a lot of people might be tempted to say, okay, I should divide by tangent. That's what it looks like. It looks like you're taking tangent times theta, but that's really not what you're doing. Tangent is a operation itself. To say that you're going to divide by tangent would be the equivalent of saying I'm going to divide by multiplication, I'm going to divide by subtraction, or I need to divide by square root. I mean, it just doesn't make any sense. To get theta by itself, you have to do the opposite of tangent. Just like if you were trying to get a number that was being multiplied by itself, you'd have to do the opposite of multiplication, you would divide. Here I have to do the opposite of tangent, which is unimaginably named inverse tangent. Actually, let me do that in a different color so you can see it a little better. So if I take the inverse tangent of both sides of the equation, it's algebra, I got to do it to both sides. So the inverse tangent of this side should be equal to the inverse tangent of this side. Running out of room, but you get the idea. So if I take the inverse tangent of both sides on this side, inverse tangent and tangent is the equivalent of saying plus 5 minus 5 times 4 divided by 4, and this just leaves me with theta. So that's what I want. I want to know what theta is. And on this side, on your calculator, it's probably second tangent gives you inverse tangent of 0.6038, and that gives me 31. Theta is 31.1 degrees. I should mention here, I should have mentioned earlier, but I forgot. Make sure your calculator is in degree mode. If it's not, then it will give you probably an answer in radians, I assume. But again, you want degrees, so make sure your calculator is set to degree mode. And that's my angle. So I found my angle now is 31.1 degrees. I can fill that in if you would like to. But that's the answer, right? I wanted to know the angle, so we got 31.1 degrees. And then for the velocity, it's down here. We got 1.55 meters per second, and that would be the answer. So again, hopefully this is helpful if you're still struggling with the trigonometry of it, because these problems, these momentum problems in 2 dimensions have lots of trigonometry. There's very little physics actually, but there's lots of geometry. This is probably someone for operation preparation, but I'm done, so thanks for watching.